And then behind me here is my new fan shroud. This is probably the, I don't know, the prototype. The 10th, 11th, or 12th, or somewhere in there, prototype of a fan shroud that I'm creating for myself. And so, obviously I put this together by hand, and they will be made by me by hand for the most part. I am tweaking kind of my process here for how to make them so they come out real nice, but and they will come out nice, but you know, I've got the fit is beautiful. I just had it actually here testing with a fan on it on the test engine, and the fit is like, you know, fits like a glove in between the, you know, the cylinder tin. That took a while to get that kind of exactly right. The screw holes are, you know, beautifully placed in terms of they line up right in the center of those grooves. So that's all good. Obviously the alternating mount, the backing plates and all that fit. Although it will come with my own backing plates that I'm designing, for the simple reason of I needed to make changes to those for just to have everything fit the way I wanted it in terms of an optimized fan for this. You know, it is designed for an oil cooler block off, so there's not a doghouse on this. So this is meant to be for external oil cooler, and it'll fit. I'll have a low profile. I can't show it to you right now because they haven't been shipped to me yet, the latest prototypes for the block off. The nice thing about the oil cooler block off is I've run oil cooler block offs before on engines, and they all just come with a gasket, and they're just a kind of cast piece with a groove in it that essentially, and that gasket just sits underneath it, and the oil just kind of spits up into that groove, and just through pressure, right, you know, will kind of get directed and go down the other side, and that gasket gets soaked in oil. Eventually those gaskets kind of just start to leak. Didn't like that. I liked really how Volkswagen did it with the silicone, you know, seals. So I've designed a low profile block off plate that'll fit underneath here, although it will take one of the upright style ones for oil cooler lines if you wanted to do that. It will ship with my low profile one, so but if you buy one of those other ones or have one of those other ones and you like that kind of setup with using the oil cooler outlets of the crankcase to do an external oil cooler, you will be able to do that. This has enough clearance to do. That's why it's curved up like that the way it is. So it does support that. The other thing that I did on this is you'll notice the directional vanes go all the way to the end. So there's no separate piece that has to be put in here. It's all interconnected inside the shroud, and they go right to the edge. So there's no extra piece that's needed to direct airflow. And you know, Volkswagen did that primarily because you know, they needed those also for thermostatic control. So this obviously doesn't have thermostatically controlled flaps in it, and won't have them. That's not really the purpose of something that will cool the way this cools. So you see that on both sides. You see them there. It's made really from basically the same thickness materials as the standard one. It's just steel. Has the appropriate, you know, part here and here for, and I'll be making the things that seal these up. So there'll actually be a little grommet in here that you'll slide your throttle cable tube through, and then there'll be a grommet piece here that will be flexible, allow this thing to kind of go up and down on the outboard side. And these are lined up perfectly with the way stock is, the OEM is, in terms of kind of where they are. So there's nothing different there in terms of, you know, throttle position or anything like that. And they're not like completely rounded off like the 36 horsepower style, partly because of the way the airflow is directed in this shroud. If you kind of do that, it's actually a little bit harder to get the right amount of airflow to cylinder head versus cylinders. So this has all been done up where you know, vast majority of the airflow is going to the cylinder head, the rest going to the cylinders. Probably 65-35 split roughly between those two. And of course there doesn't have to be anything fancy in here to redirect So that lets me do some things fan-wise, because I just got this flat surface. There's no structure in here to redirect air to an oil cooler, so that lets me do some things fan-wise. And so it's got directional vanes through here. The only thing that's left on this baby to really get completely right is right now my split of airflow between the 1-2 cylinder side and the 3-4 cylinder side is a little imbalanced. I'm actually went a little bit too far on my directional vanes over here and up at the top here. And I'm actually getting about 8% more air to the 3-4 side versus the 1-2 side. At first I had more to the 1-2 side, which actually happens even on OEM early model fan shrouds. Before they did the doghouse, there's actually an imbalance of air. The 1-2 cylinder side on the early fan shrouds actually is higher than it is on the 3-4 side. So the early cars having problems with cylinder number 3, not just because of the oil cooler, but because the air is actually imbalanced. More of the air is escaping out the 1-2 side, so the 1-2 side gets cooled more, and the 3-4 side gets cooled less. Then you add that additional restriction and extra heat from the internal oil cooler that's just sitting in the middle of the fan shroud. That's why number 3 really was problematic. And the doghouse fan shroud actually corrects that, and it corrects it actually because it uses the 1-2 side to actually redirect the air to the oil cooler. Not because they did anything super fancy different with the internal air directional vanes. They're actually pretty similar to each other. They are different, but they're pretty similar to each other, but that they stole that extra air that was going to the 1-2 cylinder side and directed it to, so they are very balanced, actually quite good. Within probably 0.5% of each other in terms of airflow. So I've got one more adjustment that's actually being made right now in terms of the laser cut parts that I put this together with are being made right now. I should get them sometime probably in the next week and a half or so. These are being made, and so I'll weld those together, fit them together, weld them together, and do some more testing. And if I have that solved, which I believe I'm going to be like super close. I mean, if it's going to be different, it's going to be really small. Then these will be kind of ready. Still have to manufacture a bunch of other things besides these. I may do these as build to order. I don't know yet, but the exciting thing is the other thing I did that's different. So my internal vanes are different, obviously, because it doesn't have the oil cooler. But you're going to get balanced, airflow between both sides. These things are all lined up where they're supposed to be lined up in terms of cylinder head and cylinder. So you're going to get really good airflow across the things that need it the most. And I made the opening larger, and there's no internal structure, so that lets me do some new things with the fan. And of course, that wider opening just reduces restriction. So this is a significantly bigger opening. And even with my last prototype of the lightweight cooling fan, next generation lightweight cooling fan, that's what I been testing this with. I have a new fan designed specifically for this that will be more optimized for this fan shroud and even provide more air. But in my very first test of measuring the actual airflow on the rig, not just measuring, because I was really focused on just measuring side to side and making sure I was getting this thing balanced, and I'm close, but still had a little bit off. And I kind of overcompensated, and I got too much air coming out the 3-4 side. The 3-4 side is this side, and not enough now on the 1-2 side. But we're making small adjustments there, and hopefully this next prototype will just clean that up, and I'll have perfectly balanced airflow. And the airflow, in terms of the measurement, was 42% higher with this fan shroud compared to the OEM doghouse fan shroud. So that's a big increase in airflow. Not what I was expecting. I was expecting an increase, but not that dramatic. And there's still optimizations to do. I think I'll be somewhere between 45 and 50% airflow improvement once I fully optimize the fan for this shroud. And so I'm pleased with how it's coming, and I think it's going to really look good. It's going to be good quality, kind of old school hand fabricated is what I'm doing with this thing. You can actually, I'll show you some of the parts and some of the things I've done. So what I did to make this is I created bucks like this. So this is like, obviously you can tell that's the bottom of that. And you can see that, that's kind of matches up with the bottom of that, right? So that's a buck for shaping that metal part. And then here's some of the air directional vanes, bent to shape accordingly to what they need. And we definitely, it's just pretty simple stuff. Just use these bucks and just use my bodywork hammers to shape them by hand, and it only takes a short amount of time. And then we fit everything together. There's slots and tabs for this. We fit it all together, weld it up, grind the welds clean on the outside, and we got a fan shroud. So it's pretty straightforward. I don't have fancy metal stamping equipment, and the tooling for stamping metal parts is actually really expensive. So that's why I'm kind of just doing the handmade approach. That may change later on if I sell enough of this stuff that we can invest in some tooling for it. But the other thing I did too with this fan shroud is in the air directional vanes, the only purpose they serve is to direct the air. The shapes of the air directional vanes in the OEM fan shrouds and then copied into the aftermarket ones are there also to do some things with accelerating air. Problem with that, and that's fine, that can help. Like what I'd really love to do maybe in the very, very long term is have a very large scale industrial 3D printer. I have 3D printers industrial scale, but a very large one that can print parts like this and actually print this whole thing, because then I can actually do some things like that with shapes inside to help with further optimizing airflow. But problem with that, generally speaking, is that while they accelerate airflow in the in the shroud, they don't overall make a much of a difference in terms of the overall airflow coming in and through and out. So they're really not helping much in terms of actual cooling of the engine. You really just have to increase airflow to make it cooler. So mine are very simple in that they just direct. They don't try to do anything else with the air, and all the optimizations for speeding up the airflow and increasing the airflow, besides keeping this really simple and having a larger inlet, is in the fan. And so that's really the secret, is having the fan, be able to, be fully optimized, and you just get a lot more air. That's why I was so surprised, because I'm like, well, all the static pressure in terms of the resistance to airflow at the heads, at the cylinders, etc., going around and through all the little tiny passages and all that is all the same. So I'm like, I actually thought that was going to be the biggest restriction in terms of airflow. Turns out that's not really the case. You can actually flow a lot more air through those fins and through all the cracks and crevices and little passages than I thought. And so, having a slightly redesigned fan shroud with different dimensions and different internals, and with an optimized fan that can take advantage of those differences in the internals, makes a big difference. So I think we're going to be, like I said, between 45 and 50% more airflow. So you got a high performance engine, don't need heaters, etc. This will, cool, significantly better than anything that's on the market today. The only thing I haven't tested is a DTM fan shroud. I hear they're very good. They're certainly balanced. They certainly are nice in that they direct the airflow, to each cylinder exactly the same in each side of the cylinder head, because it's got this kind of interesting curve to keep it straight, because obviously the cylinders are offset. But as far as I know, it uses the same fan that, and correct me if I'm wrong, if there's a different fan you can use in it. Use the same fan, so it's gonna basically push the same amount of air that anything else pushes. The placement of the air will be a little bit better, but that's about it. So there's going to be 2 versions of this. I'm going to call this Evolution 1, and it'll have just kind of standard backing plate in the front. And I've got a version 2 of this, which I haven't airflow tested yet. Same fan shroud, but it's going to have a really, really interesting fan in it. And the way air will come into the fan shroud will be vastly different. Let's put it that way. I'll show that to you later at some point. I've got to reprint some of the prototype pieces after fitting them, etc., and reprint the fan. The fan design is pretty radical in terms of how it works, but it'll be interesting to see what it does. And if it does improve the airflow more, then I'll have 2 versions of this. I'll call this one the Evolution 1, which is have an optimized fan and it'll look very much like a kind of normal piece. And then we'll have Evolution 2, which will have the radically different fan with some interesting things on the outside that make it quite different. So I know that's kind of cryptic, but I want to I'm going to show you that in a future video once I get everything fitting right, and I've got the fan designed for it, and I'm able to do some. I've got the fan designed already. Just need to make some tweaks to it and reprint those things out and do the testing. I've changed this so many times that I just kind of put that on the wayside, on the back burner for a while, because you just got to get the airflow right in this first, and then we can start experimenting more with new stuff. So excited about that, and I think you guys will be excited about it. And if you have engine, with significantly high horsepower, and you have any kind of cooling problems, this thing will really do the job for you, and it won't cost anywhere close to like what a Porsche 911 style fan shroud costs. So obviously it'll be probably more expensive than the regular aftermarket ones. I haven't really decided on pricing, but based on the number of components I have to include, etc., because it does require both outer and inner backing plates in the front, and of course you'll have to have external oil cooler, so that adds to the expense generally of the obviously cooling. But I do have now a relationship with C-Trab, and I can get their cooling parts and stuff as a dealer. Probably when I launch this, I will probably also buy some quantities of their products and have it for sale as well. So if you want to get the whole thing, with external oil coolers, fans, you name it, right? Oil filter mount. They have oil temperature. Thermostats, which I totally recommend. If you don't have thermostatically controlled on the air, you should have, in my opinion anyway, I like to build engines this way, you should have thermostatically controlled oil. They work really, really well. I had this 2110cc that's back here, has one on it, and the oil temp goes up to 180 like really quick, and then just stays there. Right, so you get your warm up, and then boom, and then the oil cooler and the fan just take over from there, and it keeps it beautiful. Of course, it can go higher than 180, but on really hot days here and that kind of stuff. But that's really kind of it for fan shrouds, and kind of my recommendation. Look at if you like the OEM Doghouse and you like the idea of the Type 4 oil cooler, definitely look at the Concept 1 fan shroud. Fits right, and if you have heater boxes and you have all that kind of stuff and you want better cooling, etc., go to the Concept 1. That's probably the best one on the market. If you can't find a OEM fan shroud, Doghouse fan shroud that is in good shape, like mine is in really good shape, so there's nothing wrong with it, so perfectly usable. But and I've been using it, and that's what I would recommend. Nothing wrong with the Scat, Impy. I don't want to throw shade at those companies. They're building a decent. They're decent. It's not that they're tragically bad. They're well balanced. They put the air where it's supposed to be. You will get some leakage around the oil cooler because of that kind of issue, and you might have some fan rubbing issues with some of the kind of tweaks in the metal internally, but that's all easily kind of rectifiable. So I don't, it's not that they're bad. So never want to throw shade at other people's products, because that might come back to haunt you. Um, so, but we strive to make something really high quality, right? The number of times I went dimensions on this and measuring the OEM and measuring the fit right after putting one together, was a lot to get it just exactly right. And to get all of this to clear, the crankcase and everything, and to have the right amount of space here, and not, have a problem with how the air flows in here. Took a lot of time and substantial investment in having these things made, welding them together, testing them out. But we're really close now. So one other thing I wanted to kind of mention too, I mentioned the imbalance in airflow and how the doghouse takes care of that. What's interesting about airflow in the fan shroud is the air wants to spin in the direction of the fan. It wants to swirl. That's one of the reasons you get more air out the 1-2 side, like even in the early fan shrouds, than the 3-4 side, just typically, because the air wants to go the direction the fan is spinning. It's kind of interesting how that works. Through tons of experiments and measurements that I've done, it became very clear that that's what was happening with the airflow, and that changed how I needed to design the internals, because I know the air wants to go, even from here around, it wants to go and go that way instead of going that way. So there's things that I got to do to kind of offset that. By, you can't just split the air right down the middle of this. Also, the fan itself is just right over partially over the 1-2 side. That also is a part of the reason that it wants to put more air there. It's just a faster escape. Air likes to go the path of least resistance, just like anything. Water does the same thing, any fluid, and that's one of the paths of least resistance. So you've got to design the internals in such a way to counteract that force, so that you get the right amount of air on both sides. And so I actually overdid it on this one, and I've got more air coming out the 3-4 side than the 1-2 side. So it shows, that it can be done pretty easily. It's just, you just got to get that tuned just exactly right, and I think my next iteration will be tuned really, really well. So if not, I might have 1 or 2 other more iterations, but it'll end up being like millimeters of difference between where I've got these air veins, etc., and not much anything else. So I know this is a long video. Appreciate if you watched the end. Hopefully people are excited about this product. I think we just keep working on cooling stuff. I think it's a kind of an area that really nobody's focused on, other than 911 style fan shrouds, which to me are not engineered well. They're kind of a copy of the 911, but they don't really copy the way the 911 fan shroud worked. It's just the same fan with the same ring in a big plenum, and it works for people because it just pushes sometimes just a lot of air. But pushing a lot of air with just a much larger fan just means more horsepower draw, right? So this will have very similar size fan as to the lightweight cooling fan. It will use a little bit more horsepower, but we're talking like a 1/4 horsepower to a maximum of about a little over 3 horsepower increase for a 45 to 50% increase in performance in terms of the cooling capacity. That's a big deal. It's a big difference. So a lot of interesting engineering work going into this, but it's been fun, and hopefully we'll get you something before too long that you guys can buy and be happy with, and that it's easy for me to put together and get to you guys. So appreciate it, and we'll talk to you again sometime soon as I continue to make the new lightweight cooling fan, next generation NGs for everybody. Manufacturing now, so hopefully it won't take too long. I'm having some problems with one of my manufacturing pieces of equipment, But working through it with the vendor. Otherwise, I'd be close to being able to start putting them back on the market, but I'm not, unfortunately. But I have more equipment coming from a different vendor, and from the testing they did for me pre-shipping, it should ship this next week to me. It looks like I'll just be able to just start producing fans without a lot of hassle. So hopefully that's the case, and if so, we'll be sooner than later, and hopefully I get the other one dialed in as well and get the problems with it fixed. I'm still waiting on another part. Some parts have broken on it and different issues. So, but we're working through it, and hopefully we'll get that thing, operational where it's producing production parts for me soon. So appreciate all the business, appreciate the interest, appreciate everything you guys have done, keeping kind of us afloat here, and hopefully this will be kind of next step in evolution of Andrig's air-cooled technology, and we'll just bring you more cooling innovations that will be good for you guys and good for your projects, and hopefully maybe become kind of the standard of what people do with their high performance engines. So appreciate it again, and we'll talk to you later. Thanks. Bye-bye.